In this video, I'm going to explain the material takeoff process. On the right, we see the blueprint or the plan page, and on the left is the material takeoff form. Now, I've already explained the overview of the plans and the takeoff form, but I want to explain something. Red Rhino has pre-built assemblies. I explained this a little bit before, but because of that, you can just count the number of receptacles and quad receptacles and GFI receptacles and data stub-ups and so on. You can just count them and list them, and then when you go and input them into Red Rhino, it'll display all the components needed for a duplex or a quad receptacle or GFI. So long story short is I use highlighters and I might pick a yellow highlighter and highlight all the duplex receptacles as I count them, okay? So I'd count all the duplex receptacles, list them on the takeoff sheet. All the quads, same thing, the quad receptacles, I'd count the quads, and I'd input them on the takeoff sheet. Now, on your handout, just highlight the different components as you count them so you don't count them twice. Now, so we can see that I've counted and input items in the takeoff page on the left. I also took off conduit. Now, I'm going to explain that in just a few minutes, but we see that there's a 12.2 MC cable, 140 feet, 12.3 MC cable on the takeoff page over here, 190 feet, and so on. Also circuit breakers. Now, let me explain a little bit about circuit breakers. On a commercial project, a lot of times they have a panel schedule that shows the panels and the circuit breakers. So I just go there and count all the circuit breakers to input into Red Rhino to capture the labor. Now here I showed that the circuit breakers cost $18. We're going to input that later, okay? And I also input, now it's not shown on the blueprints, but I added a 4S box and two 411 boxes and some wire nuts, okay? So there are certain things that you have to see through the blueprints to know that you need it. And also the blueprints are one-dimensional. So they just show a top view, if you would, of what's going on here. They don't show the switch height or the receptacle height. Again, I'm just giving an overview on how this works. Now I'm going to show a couple tools that I use for doing takeoff. I explained to you that I use highlighters, so I just get several different colors. Actually, these represent most of the colors I use. I use highlighters, and I highlight the items on the plans different colors. I might highlight all the duplex receptacles yellow, all the quads pink, all the 2x4 light fixtures blue, and so on. You can pick your own color code, but I color code these items so that I don't count them twice. Here's another little doohickey I use. It's called a tally counter. Some call it a thumb clicker counter. But long story short is I use this to count light fixtures and receptacles. Now, the plan that we're showing here is a very small plan, but you might have several floors of lighting fixtures or receptacles you have to count on commercial projects or any type of project. So I use one of these tally counters so I can keep count. What I do is I highlight, say, a light fixture, and I click the counter, okay? And highlight, click, highlight, click, highlight, click. And that way, I keep track and don't count things twice. Okay, now the third and final image I'm going to show you is a plan wheel. This is called a ScaleX. Now, a ScaleX cost about, I don't know, $60 or so. You can get them at Home Depot last I checked, or you can buy them online. Now, you don't need anything really fancy. Mine's actually black. Maybe mine's outdated. But the idea is this little wheel here, let me say it this way. Let me start over. You set the scale of the blueprints on the ScaleX. And then when you roll across the blueprints, it measures the length of conduit needed or the length of anything. So then the digital readout shows you the length that you need. And I use this again for taking off conduit. So there's two different main brands. There's ScaleX and ScaleMaster. They both work the same, and you don't need the expensive digital or Bluetooth versions, just a plain version. Okay, so I wanted to show you that tool. That's what you use for conduit takeoff. Now let me go a little bit further. I'm going over on the blueprints here, but I want to explain something. There's a couple things you need to know. As we all know, these blueprints are a single dimension, right? They're not three-dimensional. So what I mean by that is we know that the conduit has to come up out of the switch and go up the wall and then across and over to the light fixtures. And then it daisy chains light fixture to light fixture. That's about the same height, right? Same with the receptacles. The receptacles, if they don't stub down the wall, then they have to go up, over, and down with conduit, okay? So again, my purpose in explaining this is I use this scale X, set the scale, and I roll this off. Here's how to roll this off. What I do is I usually over-roll to allow for the height. Say I know the distance is 12 feet, the ceiling height is 12 feet, the switches are about 4 feet, so I just roll the scale X across the drawings till I know it's about 10 feet, and then I roll over and up, say, to the first light fixture. And then I roll slightly beyond it, called over roll, to make up for the amount that goes down into the top of the light fixture. To take off from fixture to fixture, I might start down below this light fixture to give a little over roll for the amount of MC cable that goes, again, up and down out of the fixtures. So I'll roll from this fixture and past that one, again allowing for over, or I should say over rolling, allowing for the riser, the part that goes up, okay? So I use the over roll, I just over roll to account for the amount that goes up. I do this with feeders, with MC cable, any conduits. Now, another thing I want to explain, when you're taking off conduit, always take off at right angles to the drawing. So in this case, what I would do is, as I explained, I would go roll down below that till I got to several feet to allow for the riser, and then I'd put my cursor or roller on here, my scale X on here. I'd roll over and up, straight up, again at right angles. Okay, so that's it for the rolling or how to take off conduit. Let me share something else. Another thing that's important, and I won't explain this in great detail, but this is important, is that you count the number of runs of conduit. The definition of a run of conduit is from a device to a fixture, or from a fixture to a fixture. Each one of these segmented lines represents a run of conduit. Now, the reason that you're going to want to know the number of runs is when we input this using the conduit wizard is going to show 2 connectors per run of conduit. So you need to count the number of runs. Now, over here on the left, you see the 12-2 MC cable. I show the runs equals 11. There's 11 runs. There's 140 feet total and 11 runs. Okay, so here the 12-3, there was 190 feet total and runs equals 12. Now, 3/4 EMT here. There's no on the drawing on the right again. It doesn't show necessarily the type of conduit. It shows the circuit numbers. Now, let me cover that real quick. Okay. Sometimes blueprints do show the exact size of conduit and wire. Now, in this case, I'm making an assumption that the receptacles are all fed with MC cable. So are the lighting fixtures. Okay. Since the lighting fixtures are AB, then the way I rolled this off is using 12-3 MC cable for the light fixtures because they're switched AB. In other words, they need 2 conductors to run across through the light fixtures. Now, we notice that the little arrows here with circuit numbers, A21, A22, 23, by seeing the circuit numbers here, we can determine the number of 20 amp circuit breakers that are needed, okay? So the circuit breakers are listed here. There's 5 1-pole 20 amp circuit breakers listed on the takeoff sheet. Again, it would be good if you just go ahead and practice the takeoff yourself. See if you come up with a different distance on conduit or different counts than I did on my takeoff, okay? The fact is that any 2 estimators almost on the planet would bid this job. Everybody would come up with a different amount. It's just the way it is. You want to estimate as close as you can, but go practice on your own takeoff sheet and on a blank one and fill that out, okay? We provide you with a blank takeoff sheet so you can do that. Now, last but not least of my description with conduit takeoff here is my point is that you have a certain wiring method that you use when you're doing electrical projects of how you come out of the panel. Mostly you cannot come out, well, I'll say in my instance or my experience in California, we don't come out of panels, so we can't come out of panels with MC cable, so we have to stub up out of the panel with 3/4. A lot of times what we might do is bring a 3/4 conduit up over and into the accessible ceiling space, set a junction box, and then drop down to the nearest receptacle of that circuit or circuits to catch the circuits feeding these receptacles. And that's just what I did on this takeoff. You'll notice that there's 20 feet of 3/4 with 5 number 12s. So what I did, again, how should I say it? The way I see it is I would stub out conduit here, set a junction box, and then drop down into the different circuits. Okay, so again, I explained that sometimes you have to see through the blueprints. That's one of the things you have to just know and see through. What do you actually need for home runs? Okay, so that's it for this video. Next, we're going to input the items using Red Rhino.